Okay, guys. Um, Today, what I want to do is I want to explain to you the concept of what an electrolyte is. We know that organic compounds, they contain carbon, hydrogen, and oxygen chemically bonded together, right? So that's your glucose, your fat, your amino acids, your nucleic acids. Those are the organic compounds. The electrolytes come from a group called the inorganic compounds. And again, I'm going to try and simplify it for you. That means organic compounds got carbon, hydrogen, and oxygen. Inorganic compounds don't have carbon, hydrogen, and oxygen chemically bonded together, right? I know it's weak, but a lot of you come from a chemistry deficient background, so that's as simple as it gets. So one of the things that an electrolyte is number one, it's inorganic. It doesn't contain carbon, hydrogen, and oxygen chemically bonded together. And we learned that inorganic compounds, let me give you an example. Sodium chemically bonded to chloride. This chemical bond is an ionic bond, an ionic chemical bond. And these guys are weak. And as we learned, that weak bonds, ionic bonds, when salt, the crystal salt, gets dissolved in water, and water is basically our solvent, those weak ionic bonds get broken apart. And when those weak ionic bonds get broken apart by getting dissolved in water, they will form an atom with a positive charge and an atom with a negative charge. So anytime you have a positive and a negative charge separated by a cell membrane, right? That cell has the potential to produce electricity. So electrolytes are involved in producing the electricity of your body. And as you know, the nervous system, the heart, skeletal muscle, they rely on electrolytes in order to function. So sodium and chloride are examples of electrolytes. And sodium, because it is a positive charge, is what's referred to as a cation. And chloride, because it has a negative charge, it's referred to as an anion. So you'll learn about that. They talk a lot about that when you get into clinical. So sodium chloride are two examples of electrolytes. Another example would be potassium. Right? And then my favorite, hope it's yours, calcium. All right. Then you got magnesium. Yeah. What else you got? You got iron. Yeah. Right. What else? You got phosphate. Phosphate. That's a phosphate ion. I better write that down for you. So these are all electrolytes, and they have the capability of producing electricity, right? So hang on here. So again, what is an electrolyte? It's an inorganic compound That means it doesn't contain carbon, hydrogen, and oxygen chemically bonded together. And inorganic compounds are held together with ionic bonds. And ionic bonds, by definition, are weak. And when these ionic bonds, these weak bonds, get dissolved in water, they'll break apart and they will produce an atom with a positive charge, like an example I gave you. Oops. Boom. Now, we look at this, and this is important. Let's look at where the greatest concentration of these ions are found. So we have the blood, and then we have the cell. Now, sodium is always highly concentrated in the blood, and potassium is always highly concentrated in the cell. And calcium, at least for this class, I'd like you to understand that there's more calcium in the blood than there is in the cell. And the reason I want you to understand that is that the heart and blood vessels, they rely on calcium from the blood to contract. So, and when you talk about electrolytes, there's a unit that you're going to be seeing, especially when you get into clinical and start taking doctor's orders and stuff. It's called the milli equivalent, a milli equivalent, and it's abbreviated MEQ per liter. And a milli equivalent, when you see that, you're always dealing with electrolytes. So that's how electrolytes are measured. That's how they're administered, as milli equivalents per liter. So that's a quick and dirty version of what an electrolyte is. And then I gave you some examples. So make sure you know the definition of an electrolyte, that it's inorganic, and inorganic compounds are held together ionically and they're weak. So when they get dissolved in water, they'll break apart into an atom with a positive and a negative charge. All right, I hope that helped.